So now let us discuss basic about the spring system, that what are the equivalent stiffnesses of two spring when they are connected in parallel or when they are connected in series. So first of all, suppose these two springs are connected in series. Now these are having stiffnesses K1 and K2. Now when I apply a force or when I displace this mass through a displacement delta, what will happen is there will be developing a unique particular force that would be having value equals to F, that is equals to K equivalent into delta, where equivalent K is the equivalent stiffness of these two springs. So now this force, as you can see, is equal, the force in the second spring is the same as the force in the first spring, and that is equal the force in the entire system. So here you can say that K equivalent into delta would be equals to K1 delta 1 plus K2 delta 2, where K1 and K2 are the stiffnesses of the two springs and delta 1 and delta 2 are their respective displacements. So here we can derive K equivalent as K1 delta 1 plus K2 delta 2 divided by delta. Now here we can say that delta is equals to delta 1 plus delta 2. So in other terms, if you want to derive it, so here it would be equals to delta, so that is F by K equivalent would be equals to delta 1 would be equals to K1 by F by K1 plus delta 2 would be equals to F by K2. So since the force is same in the either the equivalent spring or it is or we say the first spring or the second spring, the force will be same in all the three. So here this will get cancelled out, and what will we be left with is K equivalent is equals to 1 by K1 plus 1 by K2. So this is the formula for equivalent spring stiffness when the two springs are in series. Now let us discuss when the two springs are in parallel. And now when I apply a particular force, it will get divided into F1 and F2, but what quantity will be same in both the spring is the delta, that is the deformation of the two springs. Since we are not applying force at any eccentricity, we are assuming that this force is acting through the center of the mass, or so it would be the displacement in the two springs would be equal. So delta 1 equals to delta 2, and that is equals to delta, that is the displacement of the entire system. Now we can say that F is divided into two forces, F1 and F2. So F total is equals to F1 plus F2. So now since F is equals to Kx, so if K equivalent is the equivalent stiffness and delta is the deformation, so that would be equals to K1 into delta 1 plus K2 into delta 2. Now since we are having delta 1 equals to delta 2 is equals to delta, so K equivalent into delta would be equals to K1 delta plus K2 delta. So that would be equals to K equivalent is equals to K1 plus K2. So here we can say that when both the springs are connected in parallel, their individual stiffnesses will add up to give the equivalent stiffness of a particular spring, of the equivalent spring. So this same system we could extend through for the n number of springs. Here we are having 3 springs, so its equivalent stiffness would be 3 springs attached in series, so their equivalent stiffness would be 1 upon K equivalent is equals to 1 by K1 plus 1 by K2 plus 1 by K3. And here in the another question we are having 3 springs attached in parallel, so their displacements would be same, and K equivalent would be equals to K1 plus K2 plus K3. Similarly over here we are having 3 springs, these are in parallel. Now how these are in parallel is, if I displace this mass by a certain displacement, the displacement undergone by the three springs would be same. Suppose the mass is over here, so it would be the same displacement of this spring, and this spring, the only difference would be that this particular spring would be in compression and these two particular string would be in extension, or we can say they will get stretched out. So that is the only difference, but overall the deformation in the three springs would be same. So we can say that these three are in parallel. So their equivalent stiffness will add up simply to K1 plus K2 plus K3. Now this question again is similar to the earlier question, but over here these two springs K1 and K2 will be said to be in series because their displacement will add up and their displacements will not be equal, but what will be equal in these two springs would be their forces. But however, the equivalent spring of this K1 and K2, that is K1 plus K2 is that is equals to K equivalent is 1 upon K1 plus 1 upon K2 would be in parallel to K3 and K4 over here. Let us discuss it. K1, K2 and over here K3. This is the mass and this is K4. So K equivalent 1 would be equals to K1 K2 upon K1 plus K2, since K1 and K2 are in series, and therefore K equivalent overall would be equals to K equivalent 1 plus K equivalent 3 plus K equivalent 4, since this system and this system would be in parallel connection.